661. Aluminum reacts with oxygen to yield aluminum oxide. Calculate the mass of aluminum oxide that can be produced from the reaction of 55.06 grams of aluminum with excess oxygen if the reaction has a 65% yield. All right, the way to think of this is as a standard stoichiometry question with a cutesy finishing step. Also, you have to realize that this is the sort of question your boss would be asking you. It's asking you to solve for what we refer to as the actual yield. Right, your boss wants to know if he buys you 55 grams of aluminum, how much aluminum oxide can you hand him back? So he's interested in the actual yield. This is different from the theoretical yield. But we're going to start off calculating the theoretical yield and then use the percent yield to calculate the actual yield. So our steps, we're going to calculate that theoretical yield. 2, use the percent yield to get the actual yield. So let's begin. We're going to start this off just like you probably would if I had opened my mouth. The only number they gave us really in this problem is 55 grams. I'm sorry. My son's commenting loudly on a video game in the background. Maybe my son should shut the office door so that he doesn't creep into any more videos. You're starting off with, I was talking about the other son, but thank you very much. My youngest just apologized for the actions of the oldest. 55 grams of aluminum is how much you're starting off with. We have grams of aluminum. We don't want grams of aluminum. Grams are worthless to us in chemistry, right? The only thing we ever can do with them is go to moles. So we're going to go to our periodic table and discover that we have 26.981 6 grams of aluminum per 1 mole of aluminum. So we've gone from grams of aluminum to moles of aluminum. Cross out our grams. Now we don't want moles of aluminum. We're interested in aluminum oxide. So we go to our chemical equation and we look at that ratio where it tells us 4 moles of aluminum to 2 moles of aluminum oxide. So for every 4 moles of aluminum we have, we can produce 2 moles of aluminum oxide. We're not wanting moles of aluminum oxide. We're wanting grams of aluminum oxide. So we're going to get rid of our moles of aluminum oxide by going to our periodic table and calculating the molar mass. 1 mole of aluminum oxide contains 2 moles of aluminum at 26.9816 grams each, and 3 moles of oxygen at 16 grams each. That gives us times 2 plus 3 times 16 equals 101.9632 grams. So we've got 101.9632 0.32 grams aluminum oxide. So we've gotten rid of moles. Now we're left with grams of aluminum oxide, which is what we're looking for. So we punch all of this into our calculator. And the calculator lie you get out is 103.922. We've got 3 sig figs there, so we're really looking at 103.103, but I'm going to carry these 2 more figures through in our calculations. This is our theoretical yield. Thus ends step 1. Now, step 2 is actually more of a cutesy finishing step. We're going to use that actual yield. Real quickly, they told us that the actual yield was 65%. The percent yield was 65%. Well, remember, percent yield is equal to actual yield divided by theoretical yield times 100. So, algebraically, to solve for your actual yield, you take that percent yield, you divide by 100, and you multiply by your theoretical yield. So to get our actual yield, we're taking our percent yield and multiplying by our theoretical yield of 103.92 to get our actual yield. So basically, we're taking 65% of 104 times equals 67.5 grams. And that's your answer. Beep.